everybody. I'm going to talk about how Palo Alto Networks can secure workloads on Azure. And without much ado, let's jump into the agenda because we have a lot to cover here. I'm going to initially talk about what are the basic challenges cloud security actually poses from a network side of things, and how what are the types of use cases that the VM series are usually deployed on, and the basics capabilities of the next generation firewall and the shared responsibility model. And then we'll double click a bit into the types of deployments, the perimeter use case, the segmentation use case. And to wrap it all up and bring it home, we'll talk about automation and a little bit on CN series to just give you an idea of how native Palo Alto Networks is integrated with Azure. So, when you look at our partnership, we have an executive level of partnership with Microsoft. Our executives between these organizations are constantly engaged. Some of the collaborative efforts that we worked on is obviously one of the most prevalent ones is the transit VNet use case, where we deploy the VM series in front of the firewalls and we auto scale them. And also the Azure Security Center, the application insights, where we deeply integrate and provide mutual value to each other platform. So now let's look at the shared responsibility model. Most of the organizations are responsible for data security, and the cloud service providers usually are responsible to provide uninterrupted compute, storage, network, and some level of security on the cloud. And we can talk about how Palo Alto Networks can augment the existing security that's existing on Azure. So let's look at the various aspects of security here: the data security, host vulnerabilities, user activities, resource configurations, and cloud network traffic. And today, we're going to focus more on the cloud network traffic and look at how VM series can act as a security shield for most of the cloud network traffic that's passing through it. So basically, what are the types of challenges, network challenges that exist in Azure, network security challenges, is we might lose visibility or control. There could be multiple tools of management. And there's also lack of automation that doesn't facilitate enough security at scale. As applications scale, security needs to scale with it. And we need to have consistent tools to manage it, because it's important that we deliver consistency. And consistency is key to security, because having different security posture is just not the right security mindset. So let's look at how VM series can actually make it all better. We can regain all the visibility and control, because when VM series is deployed in between, it can look at the packets, it can look at active threats, it can also check for the policies and what is allowed and what is not allowed. Now, it doesn't do it at an individual point. It can now expand to do it consistently across all of Azure, be it deployed in a segmentation kind of orientation, or be it in a perimeter use case, be it in a data center use case, or be it across multiple other SaaS use cases too. And consistently, we can also automate and scale security. And we're going to talk much more deeply about it. Let's talk about some basic VM series capabilities here. The layer 3, layer 4, the layer 7 user-based policies. And these are policies, the first section of policies you see, which is user-based, geo-based, zone-based. These are policies that can be architected on the firewall with taking into all these variables into account. A user sitting in a different geographic region and is probably in trust or untrust, and a policy can be architected around it. Now, these are factors that are static and that influence the policy. Now, let us look at content inspection, because this has to be dynamic. So the FQDN filtering, URL filtering, data pattern, which is an interesting one, threat prevention, obviously, very interesting one, file blocking. Basically, we can look at a particular type of file, maybe a zip file, or take into account any, like, let's say a particular crypto token, and actually create a data pattern out of it and block it, or create a file out of it and block it if it's a file pattern. And most of these things are covered in threat prevention, because when the threat prevention module is established and threat prevention policies are set, all of these policies can be set with it. Ultimately, what do we bank on? The intelligence of Palo Alto Networks Threat Intelligence Cloud, because Threat Intelligence Cloud takes active information from over 69,000 customers with our Unit 42 team, which is constantly researching for new threats, and puts it all together to supply enough threat intelligence to manage all the active threats in the around the globe in an orderly fashion. And let's look at management, because now we talked about various aspects of it, but this has to be centrally managed, which is really our hybrid cloud management and panorama and tag-based policies. Because let's say you tag a policy, it can be managed with the tag itself. So that's how advanced and deeply integrated we are in Azure. So now let's look at a particular use cases: the perimeter protection, segmentation, multi-cloud security. When you think about perimeter protection, we're thinking about VM series reaching out to either GitHub or raw internet, or coming back to the data center, or it could be going to a different branch. So all of this poses active security threats when VM series is exposed, when the VMs and in the Azure VNet are exposed to all these resources. So it's very key that they pass through the VM series, get thoroughly inspected, and then are able to reach their destination safely. So let's double click into the cloud security perimeter use case. What are the actual challenges? And generally, the native challenges include the VMs reaching out to these developer resources or internet. And when they reach out, there is code exploitation that can happen, and there can be getting redirected to URLs that are not secure. All of this can be filtered at the VM series level. So whenever these VMs reach out to a particular developer resource like GitHub, they are actively filtered. Then let's look at the cloud network segmentation use case. If a critical asset is communicating between two VNets, then it can actively pass through two VM series firewall in different VNets and have them actively filter traffic, look for data patterns, look for critical PII information going between them, and be effectively reported up to the management. So, in terms of the policies, a single panorama or a hybrid cloud management can manage both the VM series and have the same effect of policies between the dev VNet and the shared services VNet. Now let's look at prevention and of unknown threats on VM series. This is another key aspect, because when an active MySQL database in this use case talks through the VM series to an unknown entity, it is obviously flagged by the VM series and sent to the Wildfire Cloud. The Wildfire Cloud is actively sandboxing it. It's a sandbox environment. It actually sandboxes this type of malware, which means it puts it in the scenario and tries to run it to actively identify the threats or a working pattern of a particular malware. And then automatically the remediations are delivered. The remediations could be actively block this connection until it's known, or allow it because we have a security patch that's already present, or we have validated that it's not an active threat. So the Wildfire Cloud is continuously looking at it and actually being able to evaluate in the dynamic fashion at scale. Let's look at then automation, because all of this is great, but it has to work at scale and it has to work at speed. So bootstrapping, XML API, and then Terraform and Ansibles and native security templates are extremely key to keep VM series at scale, because that delivers, whenever there is an application acceleration, it delivers security with it, because we are able to scale out VM series with it. Now, it's also important that the VM series not just scales out, but also has the latest updates. So the dynamic policy updates can be performed on the VM series through either Azure Storage or through Panorama. All the policies can just flow through. In terms of HTTP log forwarding, this is an interesting aspect, because now that we scaled and we also have done a lot of policy update, it's important to document it. And that's where the log forwarding comes into place, where we can automatically raise a ServiceNow ticket or any kind of a service ticketing system. Whenever the logs are automatically forwarded to that, either they are quarantined, it can be ticketed for it, any log actions can be taken. Finally, the external dynamic list. This is another important aspect because the external dynamic list helps facilitate active threads that can be blocked in a very customized fashion onto the VM series without having to make large changes onto the VM series firewall, which is you could have a simple text file that's loading onto the VM series to block a bunch of URLs rather than making a change on the firewall itself. When you double click on bootstrapping, there's an important aspect there. The whole PanOS configuration, the security files, policies, and licenses, the software update, and the dynamic content, and the Panorama device group. All of these three aspects sit in the Azure file storage, and when triggered, can quickly deploy a VM series firewall with scale and a lot of speed. Now let's look at container series firewall from a high level. The container series firewall provides threat prevention in three different methods, or three different deployment models, I should say, which is inbound, east-west, and outbound. East-west really is the lateral threats. Inbound is all the threats that are coming in, or all the traffic it can look at that's coming in into the cluster or container cluster, and the outbound, which is basically stopping the exfiltration of the container content inside the container, I should say. And when you look at the firewall for Kubernetes, it provides a complete firewall security for decades, and then it's extremely native and easy to orchestrate. What I mean by that is, from the Panorama, a container series can be orchestrated on Azure that is compatible with the Azure containers and well integrated, can be deployed in a daemon set and via network insertion very quickly. And the plugin is extremely context aware, so it can understand the context of that container. With all that said, it's important to know that all of these resources are definitely documented. There's a lot more you could reach out to us at Palo Alto Networks. And please look at all these resources. They are extremely good in terms of documentation, where we have documented the third-party templates, the reference architecture. There's a lot of discussion forums that you can benefit out of. And feel free to visit live.paloaltonetworks.com/Azure for more information. Thank you and have a wonderful day.
Hello, everyone, and welcome to this presentation on implementing effective DevSecOps for Azure. My name is David Okeyode, and I'm the EMEA Chief Technology Officer for Azure at Palo Alto Networks. I am a Microsoft Azure MVP, and I have a lot of experience working with organizations of all types and sizes to implement effective security strategies for their Azure environment. I've worked with financial services organizations, retail, manufacturing, healthcare, and education to secure organization digital assets in the Azure cloud. I have also published 2 books on Azure security, and that includes Penetration Testing Azure for Ethical Hackers and Microsoft Azure Security Technologies. So the agenda for today will start by looking at the code to cloud risks. We'll then have a look at scaling security with DevOps. We'll cover Prisma Cloud for Azure DevSecOps, and finally, I'll show you a demonstration of implementing DevSecOps for Azure in a real-world environment. The more codes that developers write, the higher the risk of introducing security flaws. A recent research that looked at a large amount of code bases found at least one security flaw in 83% of the code repositories examined. Another interesting point is that 90% of code repositories examined use open source dependencies, and this means that more development teams are relying on code written by others. Speaking of open source code usage, in many respects, development teams have shifted heavily towards a reliance on as much open source code as possible. And this makes sense from a development perspective. Open source code usage can significantly accelerate value delivery for development teams. In a recent State of Software Security research that looked at what percentage of code is written in-house versus third-party code, 97% of Java applications are found to be made up of open source libraries. With .NET, this was relatively low up until the release of .NET 5, after which the number increased to about 60%. And for JavaScript and Python, that number rounds up at around 50%. But the risks do not stop here in a code-to-cloud world. It is not just application code that we are deploying. Teams are also leveraging infrastructure codes to streamline resource delivery to cloud platforms like Azure. In a research that was conducted by our own threat research team at Palo Alto Networks, 64% of Terraform modules had at least one critical or high misconfiguration. 99% of Helm charts contained at least one misconfiguration, and 91% of container images had at least one critical or high severity vulnerability. So how do we implement security in a world where we're writing more code, we're relying more on open source code, and we're leveraging infrastructure as code to create cloud resources? Let's have a look at what a typical development process looks like. First, we have developers write the code, commit the code, and push it into a central repository. Then we have the next phase where the committed code is reviewed using both manual and automated approaches. A pull request is then opened to merge the code into the main branch. The merged code goes through QA testing before it is finally shipped or deployed to production. If we look at the time it takes for each of these phases to complete, it keeps reducing as organizations fine-tune their adoption of DevOps practices. Code review and code merge is significantly reduced as organizations adopt continuous integration. And if we look at the cost to fix security flaws, it significantly increases if they are identified at later stages in the process. This is one of the things that adopting a DevSecOps approach can help us to flip around. By ensuring that we can address about 80% of security issues at the development and code review stages before that even gets to the testing and shipping and deployment stages, we can significantly accelerate the delivery of secure value to our customers. To solve the security challenges for organizations that are adopting DevOps practices, a new approach is needed. Applying traditional approaches and attempting to retrofit them into DevOps does not work. There are three main components that need to be part of any strategy to solve these challenges. The first is to align security practices with DevOps processes by ensuring that security policies can be defined and embedded as code. And this requires taking a developer-first approach in security. The second pillar is that security feedback needs to be proactive and also enforceable. This means that development teams should not have to switch context into another tool to get the security feedback that they need. Actionable feedback needs to be embedded into development workflows. And equally important is for policies to be enforceable to ensure that organizations are not exposed to critical risks because someone decided to bypass the policies. The third pillar is that coverage needs to be comprehensive. In the digital cloud-first world that we have, more development teams are choosing to adopt an approach of using the right tooling for the right solution. What this means is that security teams need to be able to support any tooling that the development teams choose to use. If the team decides to start using Azure Container Hubs to host critical microservices in Azure, security should not be the blocker to business innovation. What we offer here at Palo Alto Networks is a platform that is packed full of capabilities to implement security in a scalable way for Azure or any cloud. Our platform includes capabilities to address development and build time challenges related to vulnerable dependencies, insecure infrastructure as code templates, secret exposed in code, or insecure source code repository configurations. Our platform also includes capabilities to address deployment and runtime challenges relating to malicious or vulnerable container or virtual machine images, overly permissive access, and cloud service misconfigurations. On top of that, we have integrations with any DevOps tooling that your teams could be using, including Azure DevOps, GitHub, Jenkins, Azure Ham, Azure Bicep, and Terraform. Now, let's go have a look at an actual implementation of DevSecOps for Azure using Palo Alto's Prisma Cloud capabilities. So here I am in an Azure DevOps console, and what you have here is security embedded into different stages of the software development lifecycle. We have security checks that are embedded into the pre-build phase, into the build stage, into the pre-deploy stage, and also at the deployment stage. And for example, if I expand the pre-build stage, you see that we are leveraging some of the capabilities to scan the code repositories and identifying misconfigurations before we even build the software. You see that we're applying checks to scan the Docker file to make sure that we're not building vulnerable container images. At the build stage, what you see here is that we're applying security checks to ensure that we're scanning the container image that's been built, and we're ensuring that it's not vulnerable before we push that into the registry. At the pre-deploy stage, we're assessing different infrastructure as code templates for Azure. In this case, assessing a Terraform template that deploys infrastructure into Azure, and also assessing an Azure Ham template. And at any of these phases, if organization policies are violated, we could enforce that and stop the pipeline from progressing. And of course, before deploying into production, we can do some additional checks and even embed application security policies at deployment time. So, what are the key takeaways from today's presentation? The first one, traditional security approaches don't work in a DevOps world. In order for DevSecOps to be successful, it must provide frictionless security for the modern software supply chain, emphasis on frictionless. DevSecOps must preserve developer productivity in order for it to be widely adopted in an organization. And also, security should not be a blocker to adopting newer cloud services and being a blocker to business innovation. And finally, Prisma Cloud offers a comprehensive platform to implementing DevSecOps for Azure. For more information on implementing security that scales for your Azure environment, please visit our websites that I have on the screen. Thanks very much and see you next time.